Hello everyone. Yeah, in this video we are going to see one of the Fang interview question. Okay, so let's get started. Okay, this is our question. So what it says is what finding the middle element of the linked list. Okay, so problem statement is given like this. So you will be given a single linked list of n nodes, and your task is to find the middle of that linked list. Okay, so expected time complexity will be O of n, and the auxiliary space complexity. So that will be the O of 1. So that means you cannot use extra space, and you have to perform the operation in O of n time. Okay, so let's look at the example now. So you can see this is our linked list. So there you can see we have 5 nodes, 1 2 3 4 5, and the middle node is 3. Okay, so output is 3. So how to solve this? To solve this problem there are two approaches. So let's go one by one. So first approach, what we can do is we find the length of that linked list, and then again we traverse and up to length by 2. Okay, so that means we traverse up to middle element. So this is our first approach. This is also this time complexity of this approach is also O of n. So it satisfy our condition, and space complexity is O of n. This also satisfy condition, but number of iterations. So we have to traverse the for loop for 2 times. Okay, though it is O of n time, but we have to traverse it 2 times. So what could be the better solution? So yeah, there is one better solution for that. So this is a slow pointer fast pointer solution. Okay, so for time complexity for this is O of n, space complexity is O of 1, and number of iterations required is also 1. Okay, so we'll see this approach. So our first approach. So in that approach, what we are going to find out is we'll find first the length of this linked list. So you can see the length of that linked list is 5. Okay, and then what we are going to do is we are iterating over this linked list and to find out the what will be the middle element. So to find a middle element, so length divided by 2. Okay, so in our case our output will be 2. Okay, so we'll start with 0 1 2. So when we reach at the middle element at position 2, we'll print the data of that element. So we have seen this is our first approach. Now we'll change the approach. Okay, let me remove this. Okay, so in the next approach what we are going to do is we'll have 2 pointers. So first one is a slow pointer, and another one is a fast pointer. Okay, so what this means, slow pointer and fast pointer means. So slow pointer means it iterate one element at a time. So first this will be at 90, then it will be at 50, then 70. But what fast pointer means, suppose at first a fast pointer will be here, then in the next iteration it will not stop here, it will directly jump to the 70. Okay, so in iteration a slow pointer will be here and the fast pointer will be here. In the next iteration fast pointer will be at 75. Okay, at that time the slow pointer will be at 70. Okay, and in the next if the 70 has next or not. So for fast pointer there is a no next node because it is present at the last node. Okay, so we'll break the loop, and where the slow pointer is pointing is at 70, so we print the data. So slow arrow data. Okay, so this will be our middle node. Okay, so we'll see its implementation, and at that time you will be understanding it more. Now we'll start the actual implementation of the code. So first let me create here one file. linked list.cpp. Okay, now we are going to import here packages as include bit/std c++.h using namespace std. Namespace std. Now, firstly, we'll create a node, class node. Here you can see we'll have two variables. First one is data, which is of type integer, and then node star pointer. Next, okay. Here we'll create one constructor node, which will take argument as data. Okay, and now what we are going to do is we are going to initialize these variables data and next inside this constructor. So how to do that? This arrow data equals to data, and this arrow next equals to null. Okay, and in the end we'll close the class with the semicolon. Now we'll write a main method, int main, inside which first return 0. Here we'll create one array of size 5, which will take parameters like 10, 15, 20, 25, and 30. Int I. Okay, so now we'll write a method to insert the data at front. Okay, so node star insert front, which will take arguments as a data and node star head. Okay, now so here what we can do is we'll create a node star new node equals to new node, and we'll pass the data here. Okay, and from here uh, what we going to do is if we'll check if head is exactly equals to null, then we'll return the new node. Otherwise what we are going to do is new node arrow next equals to head, and we'll return before returning we'll assign head equals to new node, and then we'll return the head. So I have created separate video on this how to insert data at front in a linked list. So if you have not watched that video, I'll request you to watch that video. I'll provide the link in the description box. Okay, so here we have inserted the data to the front. So we'll create the linked list. So for that uh, I equals to 4, I is greater than equals to 0, I minus. First here I'll create a node head equals to null, and then inside a for loop I'll call that method head equal to insert front, and we'll pass here first data, so array of I and then head. Okay, so this is how our linked list will be created. Now what we are going to do is we are going to find the middle of the uh, so to do that we'll go with the first approach first. Approach 1, find middle by first approach, and here we'll pass the head node. Okay, so this will be a void method. Okay, here we'll receive a head node as a parameter. Now first we'll check if head is exactly equals to null. So if head is null, then we'll write a message there, uh, linked list is empty, and we'll return from here. So now if head is not equal to null, then what we are going to do is we are calculating the length of this linked list. So we have created a new length variable here, and we'll write a method find length. Okay, we'll pass the head node. We'll create this method here. It will contain a parameter node star head. We'll check again here if head is exactly equals to null, then we'll return 0 from here. Otherwise, we have created a new variable here, count equals to 0, and then we'll create another temporary variable, node star temp equals to head. Okay, and now we have assigned value to this value of head node to this temporary node, because we don't want its value to be gone. Okay, so now what we are going to do is we are iterating over the loop, and we'll check if temp is not equals to null. If temp is not equals to null, then we are going to increment the count plus plus, and then we are moving forward. So temp equal to temp arrow next. Okay, and then we'll just return count from here. Okay, so here we are calculating the length, and when it comes out of this loop, we are just returning the count. Okay, so we have find out the length here. Now while here again we'll take a iterator equals to 0 while it is less than count, or we can simply do is we can do one thing, count minus minus length slash 2. No, what we can do is here we'll take one variable int I equals to 0, and now inside while loop we'll check while I is less than length slash 2. Okay, if it is less than length slash 2, then we'll increment the count I plus plus, and then we'll move forward the head node. So head equals to head arrow next. Okay, so after that it will break at one point. Okay, and then we are just printing the message here like middle element is head arrow data. Okay, we are returning from here. So you can see here inside the while loop we are iterating and we are incrementing the count. So first it was 0, then it will become 1, then 2. So length in our case we have length 5 and 5 by 2 is 2. So we are going to print the data of that second node. Okay. Okay, now we'll run the code. Okay, you can see middle element is 20. So you can see in our array also, so middle element is 20 here. Okay, so we'll increase one more element here. I think we can add 35 and we'll see what will be the output in case of odd number. Sorry, in case of even numbers. So you can see the middle element is 25. So you can see here middle element is this one. Okay. So now we'll change our approach. We'll write another method with the second approach. Find middle element, middle by second approach, and we'll pass head node here. So this method will take a parameter head. Okay, so here we'll create the two parameters, but before that we'll check if head is null or not. If head is exactly equals to null, then we'll just return from here and we'll print a message there. Linked list is empty. Okay, and other cases like head is not null, then we'll create two pointers here, slow pointer which will have head and fast pointer which will again have head. Now while fast arrow next, while fast arrow next is not equals to null, then what we can do is fast equals to fast arrow next. Okay, and again we'll check because we are moving the fast pointer by two elements, so we again check fast arrow next. If it's fast arrow next is not null, then we'll again move it forward, fast equal to fast arrow next, and in the end we check if fast is not equals to null. So if it is not equals to null, then we'll move our slow pointer, slow equals to slow arrow next. Okay, and when we came out of this loop, we are just going to print the data. Say out middle element by second approach, slow arrow data. Okay, Here we have printed middle element by first approach, and we'll return from here. Okay, now we'll execute the code and we'll see. Okay, I think we have missed semicolon somewhere here. It takes some time to execute our code. Okay, you can see here our middle element is 25 by with the first approach and with the second approach also. So we'll add another element here, 40, change its size to 7. Okay, and then we'll execute. So now our middle element should be 25. You can see, so middle element is 25 now. Okay, that's it for the video, guys. Thank you for watching the video, guys. If you like the video, please like, share and subscribe, and share it with your friends. See you in the next video. Till then, bye bye.